Okay, my students were complaining about problems they were having with determining algebraic expressions based on data charts. And one of the issues that they had belonged with number 9. So let's go ahead and check out number 9 and see what we can do to help them. Okay, number 9 says, complete the chart by writing an expression for the pattern. So we need to come up with an expression, and it will be an algebraic expression because it will involve variables. And what we'll need to do to determine that is we've got to figure out what is the pattern, what is the structure. That goes along with math practice number 7, I believe. We have to figure this out, the pattern, in order to get our expression. Now, in order for a pattern to exist, it must be observed at least 3 times. Let's look at our in and our out and see if we can determine a relationship. I notice right off the bat that we have 3, 4, 5, and then we have a variable b. Then we have 7, 6, 5. Now, some kids could look at that and say, well, this goes up 1, and this goes down 1. But there's another relationship that jumps out at me. Now, this all comes from number sense. You know, if you have a really good, strong number sense, you can see relationships just like that. And I see it here. I want to point something out to you, children. If you have 3 and 7 and add those two together, what do you get?
10.
You get 10. What do you get if you take 4 and 6 and add them together?
10.
You get 10. What do you do to 5 and 5? What are you going to get when you go 5 plus 5? 10. So I see a relationship where every time I add my in data with an out data, I get a sum of 10. Now, there's another way to look at it. There's another way to look at it if you want to figure out, you know, b. If you want to figure out b, like let's say that b equals 6. What will our out be? 4. If b equals 6, our out would have to be 4. If b equaled 2, what would our out have to be? 8. So it looks like to me, in order to figure out what would go here, we have to do something with b. What are we going to do to b in order to finish out our out part? What do we have to do to it? All right, what do you think, Logan?
Well, we need to put under the b a 4, and we need to switch out the b and put a 6.
Okay, now you're telling me what needs to go there, but let's say that b equals, let's say b equals 1. Am I still going to put a 4 under it?
No.
No. So what am I going to do, Logan, if I find out that b equals 1, what am I going to do to figure out what goes in the out?
You would have to multiply.
Nope, you're going in the wrong direction. I'm going to move on to somebody else. Pay attention to what they say. It might help you here. All right, well, Bradley, what am I going to do to b to find out what goes in the out?
Would you do 10 minus b?
Yes, that's what I would do. I would say 10, subtract b, and let's do that as an example. If b is equal to 1, if b is equal to 1, then 10 take away b would be 9. So if this is 1, this is 9. You got it?
Yeah.
Now, Logan, you had a little bit of trouble with this when you tried to answer a second ago. We said our algebraic expression is 10 minus b. If it turns out that this is 4, this was 4, 10 minus 4 would give us 6. If this was 2, 10 minus 2 would give us what?
10 minus 2 would give us 8.
Yeah, and 2 plus 8 is equal to 10. Right here, if b equaled 1, 1, and 9 gives us 10. So our expression that we would want to use with the pattern for out of 9 is 10 take away b. How many of you already had that as your answer for the pattern? I got one table that already had it. How many of you see now why it works? Okay, it all involves number sense. I mean, I looked at these right off the bat and I saw that together they had a sum of 10. But in order to figure out what goes in this blank here, you have to subtract the top number from 10, and And that leaves you with, that difference leaves you with what goes in the out. Okay, everybody got that? All right, let's go ahead, we'll press stop on this and make another video.